Gun-type fission weapon. This is the simplest design for a nuclear bomb, and the one used in the Little Boy bomb dropped on Hiroshima. It works by taking a subcritical mass of uranium-235, essentially a hollow cylinder, and firing a smaller uranium projectile into the center of it. The moment they combine, they form a supercritical mass, and a neutron source starts the chain reaction. It's not very efficient, but the design is so simple, it was almost guaranteed to work without ever being tested first. Implosion fission weapon, used in the Trinity test and the Fat Man bomb dropped on Nagasaki. This design is more complex. A subcritical sphere of plutonium-239 is surrounded by high explosive lenses. When detonated with perfect timing, the shock wave from the explosives compresses the plutonium core inward, increasing its density to a critical state. Plutonium cannot be used in a gun-type design because it initiates the chain reaction too quickly, so this implosion method was the necessary solution. Boosted fission weapon. This is not quite a hydrogen bomb, but a significant step up in power. A small amount of tritium and deuterium gas is placed inside the core of a standard implosion bomb. When the fission reaction starts, the immense heat and pressure fuse these gases, releasing a burst of high-energy neutrons. These neutrons cause the fission material to split much more efficiently, doubling or even tripling the bomb's yield without making the weapon much larger. Two-stage thermonuclear weapon. This is the true hydrogen bomb, also known as a Teller-Ulam design. It consists of two stages housed in a special casing. The first stage is a boosted fission bomb. When it detonates, the X-rays it emits travel faster than the explosion itself, flooding the inside of the casing. These X-rays compress and ignite the second stage, a cylinder of lithium deuteride. The fission spark from the primary causes the lithium to fuse into helium, releasing an enormous amount of energy, and, in many designs, causing the uranium casing of the secondary to fission as well. This is where multi-megaton yields come from. Neutron bomb, officially an enhanced radiation weapon. This is a small thermonuclear device designed to minimize blast and heat while maximizing the release of high-energy neutrons. The casing is often made of a special alloy, like chromium or nickel, that doesn't fission, allowing the neutrons to escape. These neutrons can penetrate armored vehicles and buildings, killing living creatures with radiation sickness almost instantly, while leaving infrastructure relatively intact. It was designed as a tactical weapon to stop massed tank invasions. Cobalt bomb. This is a theoretical type of salted bomb, never deployed, but often discussed. The idea is to encase a thermonuclear weapon with ordinary cobalt-59. When the bomb explodes, the intense neutron radiation would transmute the cobalt into cobalt-60, a tremendously powerful and long-lasting radioactive isotope. The purpose wouldn't be to destroy a city with the blast, but to render a large area uninhabitable for decades due to lethal fallout. It is the purest concept of a doomsday device. Fission-fusion-fission weapon. Most modern high-yield thermonuclear weapons fall into this category, sometimes called a three-stage bomb. After the fusion stage ignites, it produces extremely high-energy neutrons. These neutrons are so energetic, they can cause the cheap and abundant uranium-238 tamper around the secondary to fission. This final stage can easily double the total yield of the weapon, but it also produces a massive amount of radioactive fallout, making it a very dirty bomb. Electromagnetic pulse weapon. While many bombs produce an EMP, this refers to a specialized design intended to maximize that specific effect. A high-altitude nuclear detonation releases a burst of gamma rays that strip electrons from air molecules. These electrons are caught in the Earth's magnetic field, creating a powerful, oscillating electric current. A purpose-built EMP weapon would be designed to maximize this effect. frying unshielded electronics, power grids, and communication systems across an entire region without directly harming people with blast or heat.